Welcome to Schlumberger OFS QHSE Pressure Level 1 Awareness Training. Understanding pressure, what it is, how we use it, and how dangerous it can be when we lose control of it is essential to understanding the performance requirements of oilfield services. Everyone is familiar with pressure. Many cite the internal emotional buildup we suffer from time to time as the type of pressure with which they're most familiar. All of us feel tension building through frustration or approaching deadlines. All of us release that pressure at some time. Hopefully, we control it and release it in a safe and healthy way. The pressure we'll discuss here, however, is pressure that occurs naturally in our environment and pressure that we create and harness to perform work. These types of pressure are constant threats to safety at Schlumberger field locations. How the company controls the risks of working around pressure is key to our overall safety and quality programs. When we consider natural pressure, there may be no better example than the eruption of Mount St. Helens in the northwest region of the United States. On Sunday, May 18, 1980, pressure emitted from deep in the earth was released in an awesome display of power. In a matter of minutes, the entire face of the mountain was sheared away, creating a landslide over 17 miles long and decimating 150 square miles. Sadly, 91 people lost their lives. Another example of pressure in nature is a tornado. High winds blowing against structures, vehicles, and trees apply so much pressure that the objects give way. The result can be massive destruction. Through these examples, it's easy to think of pressure as force. That is precisely what it is. It can be expressed in an equation this way: force equals pressure times area. You can think of pressure as a number of small weights. At any given pressure, a larger area can hold more weights, and therefore the force against that area is increased. We most often measure force per unit of area, such as pounds per square inch. The more square inches with weight on them, the more force you can have. If you take all that weight and funnel it to a smaller opening, you can get tremendous force out of the opening, such as when fluids are pumped through a restriction. Most of the time, the pressure we confront is under control. Indeed, pressure is used by everyone as a useful tool in their lives. All of us use pressure and the force it provides. We often do so with little thought of how we have successfully harnessed its power. For example, when you ride in an airplane, it is pressure that keeps that plane in the air. The shape of the wing creates lift powerful enough to keep a giant aircraft in the sky. When you wash your car, you use pressure. Even as you drive, you ride on inflated tires that carry approximately 32 pounds per square inch of pressure. You can feel this pressure times area equation at work when you wash your car with a power washer. Holding the handle and letting the water spray into the air is easy. You can do it with one hand, as the volume of spray meets no solid area of resistance. But when you aim the nozzle at the surface of the vehicle, you likely will need two hands to hold the handle as it kicks back from the force of the water off the solid metal surface. This is an example of relatively high volume working against a small area. If the pressure is strong enough, you can peel the paint off the vehicle. Low pressure working against a large area can also produce a potent force. You witness this when you see a sailboat. Just a moderate breeze will produce about 1/10 of a pound per square inch of pressure. A typical sail may be 20 feet by 10 feet in size. Through simple math, you find the sail has about 14,400 square inches of surface area. By multiplying the area times the pressure, You see that this moderate breeze exerts 1,400 pounds of force against the sail. This is more than enough force to move the sailboat through the water. High pressure pushing against a small area or low pressure pushing against a large area can both produce a large force. That force can be dangerous and even deadly. Several years ago, Schlumberger conducted 2 demonstrations of the power of these forces. In the first one, a typical pressure pumping job was rigged up intentionally wrong. A fluid was pumped at 8,000 psi through a 2-inch line. What you're about to see demonstrates how pressure in a line reacts when the pressure exceeds the pressure limitation of the equipment being used to contain that pressure. In other words, when the pressure has nowhere to go. This second demonstration shows how low pressure can be just as deadly when applied against a large area. This bulk truck usually carries only 15 to 30 pounds per square inch of pressure. However, if the tank wall is weakened or if pressure builds beyond the rating of the containment, watch what can happen. A common type of pressure risk in Schlumberger comes from wellhead pressure. This is the natural pressure that comes from beneath the surface. You may be familiar with the old gusher photos of oil spraying high into the air as drillers puncture a rich zone. With modern technology came blowout preventers, referred to as BOPs, which are stacks of valves placed over the hole which can close in a well. While a gusher is a rare phenomenon today, oil wells still have pressure, and controlling it is key to oil and gas production. During well completion, cement is pumped between the outside of the casing pipe and the open hole. The cement forms a hydraulic seal and isolates the high-pressure zones from the rest of the well bore. The blowout preventer is installed over the open hole. After the casing is perforated to allow the migration of oil and gas into the wellbore, the cement and BOP control the wellhead pressure. Service companies such as Schlumberger open the BOP to insert tools and to pump chemicals and fluids into the well. In order to achieve this, they must produce enough pressure with their equipment to overcome the natural pressure of the well. Schlumberger OFS QHSE Standard 14, the pressure equipment standard, was created to reduce the risk to employees when working around pressure. It applies to every business segment in Schlumberger Oilfield Services and covers equipment procurement, testing and inspection, along with the training of employees. While specific segments may utilize additional standards as required by need, all must adhere to OFS QHSE Standard 14 as a minimum. OFS QHSE Standard 14 requires that only Schlumberger-approved equipment be used to contain or control pressure. Equipment that contains or controls pressure must be obtained from the Segment Product Center or from segment-approved suppliers. The design and manufacturing of pressure equipment requires special knowledge and special manufacturing processes. Pressure equipment must never be manufactured without full engineering and manufacturing process information. If you have any questions in this regard or doubt the suitability of any piece of equipment, contact intouchsupport.com to reach an expert. There are 2 more key points in regards to Schlumberger equipment. First, suppliers approved for one segment are not automatically approved for another segment. Remember, each piece must be engineered and manufactured for a specific application. Requirements and specifications vary from segment to segment and from use to use. Approved equipment means it is approved for a specific use and for a specific business segment. You should not rely on color coding or banding as the only method for recognizing the pressure rating of equipment. There have been several accidents around the world not related to Schlumberger due to 2 connections of a different pressure rating. For example, a 2-inch 1502 and a 2-inch 602 being screwed together. These connections have failed, resulting in serious injuries and, in at least one case, a fatality. It is common in Schlumberger to see many types of connections. Schlumberger testing uses both 602 and 1002 connections, although 602 connections are being phased out. Well Services uses only 1502. Many types of connections are used in the industry. Bottom line is that you have to know the difference between types of connections. If you do not know the type or origin of a connection, it should not be used. Another key point is that every piece must be approved. This includes even small pieces such as adapters. In another documented incident involving a competitor, an adapter used in a testing bay was not approved. Just as an employee became exposed, the adapter fired out with the force of a large caliber bullet. The employee was struck in the knee. His injury was permanent. There is no such thing as an insignificant piece of pressure equipment.
We're conducting a pressure test on Bay 3. Please stand clear.
OFS QHSE Standard 14 also states that pressure-containing equipment must be tested and inspected at least annually and certified according to the segment-specific requirements. In practice, each segment conducts pressure testing before each use. This occurs after rig-up to ensure all connections are sound. In addition, some segments require that the equipment be tested at the yard prior to leaving for the job. At the yard, required routine maintenance is performed on each piece to ensure that it meets specification. It is critical that any equipment that is worn beyond specifications be spotted and removed from service. There is a specific inspection protocol and record-keeping requirement within each segment due to the differences in equipment. In coil tubing, for example, the integrity of the tubing is checked by passing a steel ball through its length to confirm the ovality. A colored dye is used to make leak detection easier. Of course, accurate record keeping and using only equipment that meets specific design criteria requires that an identification system is in place. Each item of pressure-containing equipment is marked with a unique identification number. This allows a history to be built and maintained for each piece of equipment. Each segment must implement an identification system, preventing unsafe intermixing of pressure equipment of different pressure ratings. Color coding is an example of an identification system that can be used as an effective method to distinguish similar equipment between segments or within a segment. Equipment certification is key in pressure safety and OFS QHSE Standard 14. The standard requires a certification process for the manufacturers of Schlumberger pressure equipment, and it requires recertification at regular intervals throughout the life of the equipment. Each business segment is allowed to define the exact processes and procedures necessary to ensure that their pressure equipment meets or exceeds the requirements. Equipment certification is a very precise and thorough task that requires special tools and special skills. For this reason, certification is often performed by a third party. Training is another essential component of pressure safety that is addressed in OFS QHSE Standard 14. All OFS personnel that operate or work with pressure-containing equipment must review and understand the standard. This is the minimum requirement. In addition, each segment may require additional training. For example, well control school is required for some segments, while specific operator schools are required of others. In each case, people operating pressure equipment must be recertified at regular intervals or any time they have not worked at a relative field job over a specified period of time.
Once we get everything going, we'll come on with our CO2.
With correct equipment in place and training provided for employees, the next component to pressure safety is safe procedures. OFS QHSE Standard 14 is the written standard for working safely with pressure throughout OFS. However, each business segment may supplement this standard with standards written to address specific needs of that segment. Each segment-specific standard must meet Standard 14 as a minimum. However, none may supersede OFS QHSE 14 or any part of it. For example, each segment will have specific rig-up standards. Some segments work with energized fluids such as nitrogen or carbon dioxide, which require special equipment and handling. Each job must be performed by the book, but the book cannot conflict with OFS QHSE Standard 14. If there is a conflict between a Schlumberger safety standard and a client safety policy, Schlumberger will comply with whichever one is the most rigorous or stringent. However, in some situations, it might be necessary to request an exemption from a safety standard. This is a formal process, however, that requires written approval from management. Most segments have a risk exposure matrix developed that can provide guidance in seeking an exemption. A formal request will need to be made, and management will make a determination based on the nature of the exemption and the risk level involved. The final component to pressure safety, however, is the most important. That is, the individual behavior of everyone involved. From those who help track equipment records and requisition new equipment, to those who rig up the job and operate the equipment, everyone must understand the risk posed by pressure. Importantly, everyone must understand the role they play in the overall safety of Schlumberger locations and the people who work there. Everyone must understand the importance of the seemingly little decisions that they make. Decisions about posting warning signs, heeding those warnings, where you stand on location, or how thoroughly you clean or inspect equipment can have a huge effect on your safety. For example, have you ever seen someone standing near the manifold or relief valve on a pressure pumping job and thought to yourself, what would happen if that suddenly failed? At a wireline or slickline job, have you wondered what would happen if the lubricator suddenly failed? Watch this short video for an example of what can happen. Equipment can fail. Sadly, humans most often pay the price for that failure. Your company has built one of the strongest pressure safety programs in the world, but it all hinges on your decisions and your professionalism. Certified equipment, certified training, and written procedures will work to protect everyone as long as everyone does their job. Just like that job with the pressure washer, it all depends on you. By the way, next time you use that pressure washer, make sure the equipment is in good working order, read the instructions carefully, and follow them to the letter, because as soon as you drop your guard, something unexpected can happen.